Welcome back, everyone. We're diving into a topic today that's, well, pretty much out of this world. Cybersecurity for space systems. You might be thinking, space? Isn't that like rocket science and astronauts? And yeah, it is, but it's also a lot more than that. We're talking about the systems that we rely on every day right here on Earth, like GPS, for example, or the satellites that handle global financial transactions. It's incredible how much we depend on these systems up in space. But here's the thing. They're vulnerable. Remember the NotPetya cyber attack back in 2017? It caused chaos for businesses all over the world. But what's really interesting is that it also had a huge impact on space. Turns out, a major software company that works with the space industry was hit hard by the attack, causing delays in satellite launches. Who knew something designed to disrupt shipping could end up affecting something as complex as space exploration?
Yeah, it's wild, isn't it? That incident really highlighted how interconnected everything is these days, and how a cyber attack in one area can have a ripple effect across completely different sectors. When you think about it, we rely on space systems for so much: communication, navigation, even intelligence gathering. If those systems go down, it could have massive economic, political, even military implications.
Okay, so let's get specific. What kind of cyber threats are we actually talking about here? What are the bad guys trying to do?
Well, think of it this way. Almost anything you could do with a computer on Earth, someone could potentially do to a satellite or ground station.
Hmm.
We're talking about eavesdropping on sensitive communications, trying to spoof signals to mess with navigation systems, and even, well, this might sound like something out of a movie, but there's the potential for hijacking entire satellites.
Hijacking a satellite, that sounds terrifying. What would that even look like in the real world? What would be the impact?
Well, imagine if someone took control of a satellite's imaging capabilities. They could use it for espionage, or even to target critical infrastructure on the ground. Or think about what would happen if they messed with a navigation satellite. Planes, ships, even cars could be sent off course. The consequences could be disastrous.
Okay, that's pretty scary stuff. So, how do we even begin to protect these systems? It's not like we can just send an IT guy up there with the toolbox, right?
Right. The challenges of operating in space are completely different from what we face here on Earth. We're talking about systems that are thousands of miles away, with limited resources, operating in harsh environments.
So, does that mean our typical cybersecurity methods just don't work in space?
Not necessarily. A lot of the basic principles still apply: strong encryption, access controls, constant monitoring. But the way we implement those principles has to be adapted for the unique challenges of space. For example, we have to factor in things like communication delays, the fact that you can't physically access a satellite once it's up there, things like that.
So, it's like taking those core cybersecurity principles and putting them on steroids, basically.
Yeah, you could say that. And we're also seeing a lot of innovation in terms of the specific strategies being used. One approach is to make the satellites themselves much more secure, building in layers of protection right from the start. Think things like tamper-resistant hardware, software that can detect intrusions, even systems that can self-diagnose and recover from certain types of attacks.
Wow, that's amazing. So it's like giving the satellites their own immune systems to fight off digital infections. What else are we doing to protect these systems?
We're also focusing a lot on the ground systems that communicate with and control the satellites because, let's face it, a vulnerability in a ground station could be just as dangerous as a flaw in the satellite itself.
Yeah, that makes sense. It's about protecting the whole ecosystem, not just the piece that's actually floating in space.
Exactly. And we're seeing more and more collaboration between different organizations, both government and private, to share information about threats and vulnerabilities. This kind of information sharing is crucial for staying ahead of the bad guys.
It really highlights how cybersecurity in space is a global issue, not just something for individual countries or companies to worry about.
You're absolutely right. International cooperation is essential, especially as space becomes more crowded and contested. We need to establish common rules of the road, share information about potential threats, and work together to prevent cyber attacks that could disrupt critical systems for everyone.
You make it sound like we're heading towards a future where space isn't just a frontier for exploration, but also a potential battleground for cyber warfare. Is it really that serious?
Well, it's definitely a possibility we need to be prepared for. But it's not all doom and gloom. There are some incredible developments happening in the world of cybersecurity, things that could completely change how we protect our space assets in the future.
Okay, now you've got me intrigued. Tell me more about these game-changing technologies.
One of the most promising areas is something called zero trust architecture. It's a pretty radical shift in how we think about security.
Zero trust. What does that even mean when we're talking about space?
Well, traditionally, cybersecurity has been all about building walls, right? You create a perimeter around your systems and assume that anything inside is safe. But with zero trust, you basically assume that no one and nothing can be trusted automatically. Not even users or devices within your own system. You're constantly verifying and validating every single request.
So it's kind of like being suspicious of everyone all the time, even your own team.
Pretty much. Every time someone tries to access something, every time data is transmitted, it's scrutinized. It's like having layers of security checks at every single point. So even if an attacker gets through one layer, it's really hard for them to move around and do more damage.
That sounds incredibly secure, but also incredibly complicated. How do you even design something like that for something as massive and intricate as a space network?
It's a huge challenge, for sure, but the payoff is potentially enormous. And we're already starting to see some of the building blocks being put in place. For example, newer satellites are being equipped with advanced authentication systems, so it's not just a simple password anymore.
So it's like giving each device and user a unique digital fingerprint, so imposters can't just sneak in.
Yeah, exactly. And some satellites are even being designed with something called secure enclaves. These are basically isolated areas within the system where the most sensitive data and functions are protected even further.
Like a vault within a vault.
Exactly. Makes it much harder for attackers to get to the really critical stuff. But, even with all this advanced technology, we can't forget about the human element.
Yeah, that's what I was thinking. Even with all these fancy systems, can't someone still mess things up? What if someone falls for a phishing scam or accidentally misconfigures something?
Oh, absolutely. The human factor is always going to be a concern. That's why cybersecurity awareness training is so important, even for people working in space. Everyone needs to understand the risks, how to protect themselves from social engineering attacks, all that stuff.
It sounds like a never-ending game of cat and mouse, attackers trying to find new ways to exploit weaknesses, and defenders trying to stay one step ahead.
That's a pretty good way to put it. But it's not just about reacting to threats. We're also working on proactive measures that could really change the game. One of the most exciting areas is quantum communication.
Quantum communication. Okay, now we're getting really futuristic.
It might sound like science fiction, but it's closer than you think. Quantum communication uses the principles of quantum mechanics to create communication channels that are basically unhackable.
Okay, hold on. I vaguely remember learning about quantum mechanics in school, but it always seemed really abstract. Can you explain it in a way that makes sense for space cybersecurity?
Sure, imagine you're sending a message encoded in photons, which are tiny particles of light. These photons have this crazy property called entanglement, which means they're linked together in a way that even if they're separated by huge distances, what happens to one affects the other.
Entanglement. So it's like two photons connected by an invisible thread, even if one is on Earth and the other is orbiting a satellite.
Yeah, that's a good way to visualize it. And here's the key thing. If someone tries to intercept or eavesdrop on one of these entangled photons, it messes with their quantum state, and that disturbance is immediately detectable at the other end.
So it's like a built-in alarm system that goes off if anyone even tries to peek at the message.
You got it. And because this is based on the laws of quantum mechanics, it's not a matter of building a stronger encryption algorithm or anything like that. It's basically using the fundamental laws of nature to make communication inherently secure.
That is mind-blowing. So quantum communication, that sounds like it could be a real game changer for space cybersecurity. No more eavesdropping, no more data breaches.
It has the potential, yeah. But it's still early days. There are some big engineering challenges to overcome before it's widely used.
Like what?
Well, creating and maintaining entanglement over long distances is incredibly difficult. You need extremely precise equipment and really complex control systems.
And I imagine it's not exactly cheap either.
That's another factor, yeah. But like any new technology, we expect the cost to come down over time. But while we're waiting for quantum communication to become a reality, we're not just sitting around. We're still working on improving our existing cybersecurity approaches. And one area that's getting a lot of attention is artificial intelligence.
AI in space. I feel like we're back in science fiction territory again. How's that being used to protect our space assets?
Well, AI is amazing at analyzing huge amounts of data and finding patterns that might indicate a threat. So in space cybersecurity, this could mean monitoring telemetry from satellites, network traffic between ground stations and spacecraft, even social media for signs of a planned attack.
So it's like having a digital detective constantly on the lookout, trying to find that needle in the haystack.
Exactly. And the cool thing about AI is that it can learn and adapt, becoming more sophisticated over time.
But couldn't attackers use AI too?
That's a valid point. AI is a tool, and like any tool, it can be used for good or bad. So we need to be aware of that and develop strategies to counter the potential for AI-powered attacks.
So it's like an arms race, with both sides trying to use AI to their advantage.
In a way, yes,
Yeah.
but it's also an opportunity to develop more resilient and adaptable security systems. For example, researchers are looking at using AI to create self-healing systems that can automatically detect and recover from certain types of attacks.
That's incredible. So the satellites could basically fix themselves if something goes wrong.
That's the idea. And we're also seeing AI-powered tools that can help human analysts sift through all the data and focus on the most critical threats.
It seems like AI is going to become an essential part of space cybersecurity. But even with all these amazing technologies, isn't there still a chance that something could slip through? What happens if there is a successful cyber attack on a space system? What's the plan?
That's a really important question. And it's something that space agencies and companies are taking very seriously. Just like we have incident response plans for cyber attacks here on Earth, we're developing similar protocols for space.
But responding to a cyber attack on a satellite thousands of miles away, that's got to be a lot more challenging than dealing with a compromised server in a data center.
Absolutely. One of the biggest challenges is the time delay. It takes time for signals to travel back and forth between Earth and a satellite, which can make it really hard to make decisions and take action quickly.
So speed is critical. Every second counts when you're trying to contain a cyber attack.
Exactly. And that's why we're seeing a lot of work being done on technologies that can automate parts of the incident response process. For example, some newer satellites are being designed to automatically isolate themselves from the network if they detect something suspicious.
Wow, that's smart. It's like giving the satellite a way to protect itself while the humans figure things out.
Exactly. And beyond automation, we're also working on improving our forensic capabilities so that if an attack does happen, we can figure out what happened, assess the damage, and try to prevent it from happening again.
So it's not just about stopping the immediate threat, but also about learning from it and making the system stronger in the long run.
That's exactly right. And that's another area where international cooperation is so important. Sharing information about attacks, vulnerabilities, best practices for incident response, all of that can help everyone improve their defenses and create a more secure environment for everyone operating in space.
It's like that old saying, a rising tide lifts all boats.
I like that. And as we move forward, it's important to remember that space cybersecurity isn't just about technology. It's about protecting the systems that allow us to explore, learn about, and connect with our universe.
You've given us a lot to think about. It's clear that this is a field that's constantly evolving. What are some of the key trends on the horizon? What should our listeners be paying attention to as we continue this journey into the future of space exploration?
One of the most significant trends I see is this: how space and cybersecurity are converging with other emerging technologies.
Convergence, what do you mean?
Think about fields like artificial intelligence or AI or even biotechnology. These are all areas that are developing really rapidly, and they're starting to intersect with space exploration and cybersecurity in some really interesting ways.
Okay, I'm following you. Can you give me some specific examples of how these different fields are actually coming together? I mean, I know we've already talked about AI a bit.
Right, we talked about how AI is being used for threat detection in space systems, but AI is also playing a big role in the development of autonomous spacecraft, which could completely change the way we do everything from scientific research to space-based manufacturing.
Autonomous spacecraft. So are we talking about like robots in space,
Right.
making decisions and carrying out missions without humans directly controlling them?
Exactly. And as these autonomous systems become more complex, they're going to need even more advanced cybersecurity to protect them. We can't have some rogue AI running loose in space.
That does sound like something straight out of a sci-fi movie. Okay, what about machine learning? How does that fit into this whole convergence thing?
Well, machine learning is a type of AI that basically lets systems learn from data without having to be specifically programmed. So in the context of space cybersecurity, we can use it to create security systems that can adapt and respond to new threats as they pop up.
It's like giving the satellites the ability to learn and get smarter over time.
Yeah, that's a good way to think about it. And that ability to learn and evolve is going to be super important as the threats in space become more and more complex.
Okay, I get that, but biotechnology, how does that relate to space and cybersecurity? It seems kind of out of place.
It might seem like a stretch, but biotechnology is becoming a bigger and bigger part of space exploration. Think about things like life support systems or astrobiology, the study of life beyond Earth.
So like bioengineered plants to grow food in space, or microbes that can help us mine resources on asteroids.
Exactly. And all those bioengineered organisms could be vulnerable to cyber attacks as well. Someone could manipulate the genes of a food crop on a space station or mess with the balance of a life support system. It's pretty scary when you think about it.
Yeah, no kidding. It's like the more advanced that our space systems become, the more potential there is for something to go terribly wrong.
That's why cybersecurity has to be baked into every aspect of space exploration right from the start. It can't be an afterthought.
So it's not just about protecting data and systems, but also about protecting human life and the integrity of scientific research.
Exactly. And the further we go into space, the higher the stakes become.
You've given us a lot to consider. It seems like we're entering a new era where space, cybersecurity, and all these other technologies are becoming more and more interconnected. What does that mean for us regular folks back here on Earth?
It's tough to say for sure, but I think this convergence is going to have a huge impact on our lives in all sorts of ways.
Okay, for example.
Well, for one, I think we're going to see a massive increase in the amount of data coming from space. Satellites are already gathering tons of data about our planet,
Hmm?
weather patterns, agriculture, even the movement of people and goods. As space sensors get better and better, we'll have access to even more data, and that could change everything from scientific research to urban planning to disaster relief.
It's like having a giant eye in the sky watching over everything. But all that data has to be protected, right?
Absolutely. We need to make sure it's secure from hacking and tampering. And we need to develop systems that can handle all that data and make it useful for researchers, policymakers, and the public.
That sounds like a pretty big job, but the potential benefits seem worth it. So, what else do you see happening as space exploration and cybersecurity continue to evolve?
I think we're going to see a huge demand for people with expertise in these areas. As more companies and organizations get involved in space, they're going to need people who understand the unique challenges and can develop secure systems.
So, we're talking about a whole new generation of space cybersecurity professionals.
Exactly. And not just cybersecurity experts, but engineers, scientists, lawyers, policymakers, everyone who can contribute to making space a safe and sustainable place.
Well, that sounds pretty exciting. But let's bring it back down to Earth for a minute. What can our listeners do if they're interested in learning more about space cybersecurity, or maybe even getting involved in the field?
The most important thing is to stay informed. There are lots of great resources online and in libraries.
Any specific recommendations?
Sure. The Space Information Sharing and Analysis Center, or ISEC, is a great place to start. And the Secure World Foundation is another organization that does excellent work in this area.
Perfect. We'll make sure to include links to those in the show notes. What about people who want to go beyond just reading and actually do something?
There are tons of different paths people can take. If you're tech savvy, there are opportunities in software development, systems engineering, security analysis. And for people who are more interested in policy, there are roles in government agencies, think tanks, and advocacy organizations.
So there's something for everyone who's passionate about space and wants to help make sure we're exploring it responsibly.
Absolutely. It's a growing field with a lot of opportunity to make a real difference.
Well, this has been an incredible conversation. We've covered so much ground, from the nitty-gritty of satellite security to the big picture of how space, cybersecurity, and other technologies are all coming together. It's clear that there are lots of challenges ahead, but there's also a ton of innovation and excitement in this field. Thanks for joining us on this deep dive.
It was my pleasure.
And for all our listeners out there, stay curious, stay informed, and as always, keep looking up.